Hi friends, this is your friend Patodia from askIITian IIT Maths. Now you must be knowing me, okay? So today, guess what we are here for? So have you ever encountered questions like 2 raised to power 91, what is the last two digit of such big number? Or 3 raised to power 105 divided by 4. So to answer this question, I present you binomial theorem, okay? So our journey will be having 9 breaks in between, and with each break your level of understanding will increase. Now coming to the crux, that is IIT-JEE. Now this chapter again has good weightage in IIT-JEE. Why? Because it is indirectly used in permutation combination, which in turn is used in probability. Also it will extend up to calculus also. So again, binomial forms a very important part as far as basics are concerned. And during the journey, I'll start with basic knowledge of factorial notation, a new operand which you will learn here, and after that we will be going for IIT advanced concepts, which will be basically in 3 miscellaneous parts. Before that, we will be also studying about some binomial coefficients and their properties, which you are wondering right now what are those. Okay, so let's start with our journey, and we'll do introduction and bit of binomial in our first part, and then we will carry forward our journey to reach binomial coefficients and the miscellaneous, which will be forming the crux of IIT-JEE. Let us start with looking at the contents first. So in this journey, we are going to look at introduction, then binomial theorem, which these two will be forming the crux of this part. Then we will be studying important terms in binomial, numerically greatest terms in the coming parts, binomial coefficients and their properties, and miscellaneous. So this will form the composition of our journey, okay? So let's begin with the introduction. What is a binomial? Firstly, we'll break binomial theorem in 2 parts. So binomial, as all of you must have been studying, is a polynomial having 2 terms. Okay, so binomial is anything having 2 terms. Okay, and binomial theorem is all about studying that when the binomial is raised to some power, then how we can easily operate with that. Okay, so as stated, it describes the algebraic expansion of the powers, and according to binomial theorem, okay, so if I give you x plus y raised to power 2, you are able to do that. If I give you x plus 2 raised to power 4, you will still be able to do that. If I give you x plus y raised to power 4, 8, you will still be able to do that. But what if I give you x plus y raised to power 800? Now you will scratch your head that, oh my god, how we can multiply? So binomial theorem gives us the possible solution, that how easily we can expand according to a given formula that we will derive soon. But before that, let us look that it says that x plus y raised to power n, okay, as I said that suppose the power is 800, okay, in this case. So clearly this n will become 800, and then it will, binomial theorem says that it is possible to express this into axb, where this I am saying as part or one thing when I am expanding this. So it is possible to expand this in terms of axb y raised to power c, and where the condition is b plus c will be equal to n. Now this power basically n we are distributing over x and y, okay? So that is why it forms x raised to power b and y raised to power c, and their sum should be equal to n, and the coefficient a is what we will get from the binomial theorem. That is the crux of binomial theorem, okay? So before going to that, we need to study factorial notation. Now all of us has been doing plus, minus, multiplication, division. Now here is the time to study one more operation that is known as factorial, okay? So like we add 2 numbers, we subtract 2 numbers. Factorial notation is applicable for one number only. Means the symbol factorial is on your screen right now. So factorial is applicable for single number only. For example, if I write 5 factorial, okay, now what does the factorial notation do? This factorial actually means that the number which I am writing, I will be writing it in the form of numbers less than that in the product of that. Means I will be going up to 1 and it is a product of consecutive numbers till the number which we are required. For example, if I am writing n factorial, what does that mean? It means n into n minus 1 into n minus 2 till 1 factorial. Okay. Now this is very important, as this is a basic operation which is being used in binomial theorem. So you need to be focused and you need to be pretty careful with the factorial notation and make yourself comfortable with this notation. And one thing again to note here is that if you are doing n into n minus 1, now this I can again write as n into n minus 1 factorial. A very important thing, that when we are doing factorial, what is the basic crux? That we have to go till 1 and consecutively multiply every number which is 1 less than the previous one. Okay, so 5 was multiplied by 4, which was multiplied by 3, 1 less than, okay, till 1. So for n, if I am writing, suppose I want to write 4 factorial, so I can write it as 4 into 3 factorial. I can write this as 4 into 3 into 2 factorial. Okay, and obviously 2 factorial is very understandable, 2, and 1 factorial is again 1, because 1 into, you will be left with that. Now interesting thing here is that 0 factorial, how do we do that? Okay, now again, one thing important to note here is that factorial is defined only for whole numbers, or I would say non-negative integers. Okay, so 0 is again a part of that. So using this formula we can get 0 factorial. Now if I put 1 factorial here, n as 1, so it will be 1 into 1 minus 1 factorial, that is 1 into 0 factorial. So from here I can get 0 factorial as 1. So I will suggest students to at least learn up to maybe 6 factorial. So 0 factorial is 1, 1 factorial 1, 2 is 2, 3 is 6. You don't need to do anything till 3. 4 factorial 24, 5 is 120, that is 24 into 5. So now if you want to have 6 factorial, you can just write it as 6 into 5 factorial. So 5 factorial you have derived as 120. So from here you can write it as 720. You can even remember up to 8 or 9, it will be better, because again these will be used quite often in the binomial. So we will see their usage, and I guess this operation is clear, that this is again one type of, but the earlier operations which we have done were binary operator. This is a unit, this is applicable to single number. Okay, so single number using operator. Okay, so after that, let's see, start with the binomial and we'll correlate it with the factorial notation later on. So we start with the power 0, that is very easy for all of you, only one term. Then next comes x plus y raised to power 1, 2 terms. Again going like this, 3 terms, 4 terms, 5 terms. Okay, so one thing which we have noted from here is that between the relation between the power and the number of terms. Okay, so this is the power, the number of terms is 1 more than the power. Okay, that is the first important result, 1 more than power, or we call it as index. Okay, and one thing again to note, that right now we are studying here in this part specifically for only natural numbers or whole numbers. We will be doing the powers, and again there will be 2 cases which will be discussed later. This is for the whole numbers, and that will be for rational number or any power, means if it's half also, minus 1 also. Here we are just going for whole numbers. Okay, so one thing we have noted down here, that this is, and again as we are noting it down that x plus y, this is x square plus y square plus 2xy, x cube plus y cube, some pattern is being there. Like if you go from this to this, you're always seeing that the first and the last term, they're having the same coefficients, always 1. In the middle one, it's being increased. Now, here it further clarifies that as you're going from x to x cube to x square to x, okay, there is some symmetry. Like for y4 and x4, the coefficients are same. X cube and y cube coefficients are again same. X square, y square is the highest coefficient. So again, we are going to exploit this pattern, okay. And again, one more thing, that when we are going to expand any power, okay, the first term will be first term of the binomial raised to the index, and then it goes on decreasing, okay. If I am writing x plus y raised to power 100, okay, so I know this for sure that it will start with x raised to power 100, x raised to power 99, and again it will start with y raised to power 0, y, and then it will go up to x raised to power 0. Now this is for sure, this is the pattern of variables. Now we need to find, obviously for first term the coefficient is always 1 and the last term it's always 1. That's we have observed, and this I'll explain it again in more detail, okay. So right now just some patterns which we are going to observe, okay. So from here in this it's clear that the powers of first term are decreasing by 1 and second are increasing by 1. The only thing now left is these coefficients, okay. So let me mark it. The only thing left is these coefficients. So we need to figure a way that how these coefficients are actually getting involved, okay. So have a look on that, okay, when we will study about this, okay. So now here basically the pattern which I was talking about is listed here, that the things which we observed here, this was 1 1 1 2 1 1 3 3 1, which are basically the coefficients, because we have done our part on the variable. Now the only thing which is being of concern is the constant or the coefficients of variable powers, okay. So that is being done here, right here. So as we were seeing, the first term was 1, second was x plus y, third one was x square plus 2xy plus y square. So again the coefficients are listed here. This one again x cube plus 3x square y plus 3xy square plus y cube. As you can see, these are coefficients. Now is there any relation that we can draw, we can get the coefficients of next, okay. So let's look. I can predict the coefficients of next even if I don't have this data, okay. I'll do it here, okay. So this is given 1 4 6 4 1, okay, but how does it come, okay. So this one comes from addition of this. Now here we suppose there is no term, okay. 1 plus 0 will give me 1, okay. Now 1 plus 2 has given me 3, 2 plus 1 again has given me 1, and this one is come from 1 and 0. Now in the same way 1 will go from here, then 4 comes from 1 3, 6 comes from 3 3, 4 comes from 3 1, 1 comes from, okay. So now you will say that, okay, this was written. So again, if you want to derive next one, it will be 1 here, 9 here, 36 here, then it will be 84 here, 126, 126, 84, 36, and 9 and 1, okay. So it will go symmetrically, okay. And again, so this was raised to power 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this way we can do, but it's not possible if I again give you x raised to power 100, maybe x plus y raised to power 100. You won't go for 99 and then find the 101, okay? So there needs to be some pattern, okay? And as you can see the other triangle, okay? Now these triangles, they are known as Pascal's triangles. Basically he correlated, he first listed the coefficients, and then now these notation, okay, these are again the denotes combination, okay, and this is again an operation, okay. Now it's again, as you can see, there are two numbers, one is a superscript, one is a subscript, okay. Now here it says basically the upper one is the index, that will be, which was x plus y raised to power 0 here, okay. As you can see in this row, index is 1 2 3 4 5 6 7 8, okay. So as you can see, this is index, and the lower one is the term number, okay. Now in this, the first term was x, so c0, okay. It will start from 0. Why? Because the first term we are saying, again we are having one more term, okay. So this c notation, again, those, some of you might have been doing this or maybe familiar with this. So this is basically nothing now but we represent this as, this is basically binomial coefficient, okay, and this is nothing but n factorial over r factorial over n minus r factorial. Now this r represents basically the position starting from 0. Again, that is key to note that we will start from 0, because since for 0 terms we were having one term, for 1 we were having 1 and 2 terms, so we are not saying 2 terms, we are starting from giving this term as 0 number, this as 1, okay. So in terms of that, it's easy to memorize that it will start from 0, nc0, and it will go till ncn, okay. Now these are the coefficients basically, okay. Now if I will be writing x plus y raised to power 100, now this is the crux of the binomial theorem, that we have first done the xy, that how they are going to decrease, and now we have figured out the way how this power is going to be distributed, okay. We'll look about this triangle in more detail. Again, these numbers you can find yourself that these are related to this, okay. We will be using more of this. Again, you need to be comfortable with this notation, okay. So let's see. Again, as I said, these are known as Pascal's triangles. So binomial theorem, again, this is a very general form given here, x plus y, a plus x, same thing. So as you can see, this is the first observation we had, that whatever is the power, we are going to start with that, decrease it 1, increase the other by 1, okay. This was part already well explained. Now this is of the concern. Again I will give basically more realistic part in the coming realistic part of these coefficients in the coming videos. For this video, it's limited that you are understanding this in terms of binomial coefficient, okay, and this is an operation for you right now, which represents, if I am writing nc0, it means n factorial over 0 factorial n minus 0 factorial, which is again n factorial over n factorial equal to 1, okay. Now nc1 again will be n factorial over n minus 1 factorial 1 factorial. Now again we will use here this n factorial as n into n minus 1 factorial. So this will get cancelled out and we will get n. Now let us see that I'll expand this one using the above coefficient, okay. So this one was x square plus 2xy plus y square. Again, you should not write it as x square plus y square plus 2xy. Then it will get disturbed, because the rule says first variable highest power, decrease it by 1, then again decrease it by 1, okay. So that is a crux, okay. You don't need to lose that thing. And again, now I will be writing in terms of NCR notation, okay. So this will go like this, x plus y square. Now index is 2, so obviously the upper index, the superscript one, will be 2. We'll start with 0, 2c0, and x raised to power 2 plus 2c1 x raised to power 1 y raised to power 1 plus 2c2 x raised to power 0 y raised to power 2, okay. So we are getting x square, xy and y square. Let us look. 2c0 again is 1 only. Why? Well, just now we have done nc0 is, so even if it's 2 doesn't matter, it's 1, x square only, plus now 2c1 I'll show here, It's 2 factorial over 2 minus 1, that is 1 factorial into 1 factorial. So this will again be 2 only. So 2xy, and on the similar basis 2c2, it will, this term will be 0 this time, and this term will be 2. So 2 by 2 will again give me 1 only. So this will be plus y square. So as you can see, this is applicable to square. So now if I give you x raised to power 100, x plus y raised to power 100, basically you don't need to worry now. How you will write? 100 as a superscript, then c0 you will start, first term highest power x raised to power 100, plus upper one will always be same, the superscript, only the subscript will change, it will increase by 1. So as the power, which will be x raised to power 99, it will decrease, and y. And the key thing to note here is the overall power of the variable terms is the index only. Okay, so we start from 0 till full, okay? And the power always remains, the sum of power always remains that. So it will end like this, 100c 100 and y raised to power 100. So this was the crux of binomial theorem, that again I'll use a new sheet for this. Yeah. So whatever I just said, that this one, x plus y raised to power 100, so this was starting with 100 c0 x raised to power 100 plus 100 c1 x raised to power 99 y plus, and it will go on 100 c100 y raised to power 100. Okay, so now this is the basic crux right now, that we are able to expand, which was seeming a bit of very difficult task in the beginning. Okay, so this is the crux of the binomial theorem, that how we are gonna use the index, and this I'm gonna explain in more detail in the coming videos. Obviously, for right now you just need to know that NCR is nothing but n factorial over n minus r factorial into r factorial. So that is for this presentation. Make yourself comfortable with factorial notation, go back, revise again, and see that how we are gonna write the expansions, maybe of x plus y raised to power 12. You can try for 24. You don't need to write each term basically. Okay, obviously index is 12, so there will be 13 terms, and you start with x raised to power 12 and go up to x raised to power 0 and increase y by 1. Okay, so that will be, just make yourself comfortable with this. Okay, we will be doing more realistic part of this, that what actually this is, how this is distributed like this. Okay, everything will be discussed, but right now this is it for this video. So here we are at the end of our first part, and I hope that the basics of binomial and the pattern recognition, the main aim of this part, was being cleared, and I hope that you will be making yourself comfortable with the binomial, and we will be studying about the binomial theorem in detail in the coming parts. Stay tuned for that.